deadly new war machine struts its stuff, the Comanche, designed to prowl the digital battlefields of the 21st century, capturing images of the enemy in split seconds, then killing from cover.
It hasn't changed any from Eddie Rickenbacker's days. You have to be seen to be shot.
Comanche, Battle Scout, next. With the Comanche, the helicopter emerges as one of the most significant new weapons of the 20th century. From a perch in the air, it will change the face of war on the ground. The Comanche is an armed scout, but it will not only locate enemy forces, it will orchestrate the battle, call in artillery, attack helicopters and airstrikes, while providing a ground commander with a bird's-eye view of the battlefield. It's a compact bundle of sensors, computers, digital communication systems, and weapons. It cost more than $2 billion to put this one lonely Comanche into the air. It represents 15 years of development, 4 years of test flights, with 5 more to go. Heavy attack helicopters like the Apache, big and vulnerable, need to know what they face when they head across a front line. They are too valuable and too vulnerable to head out on fishing expeditions. That's the job of a scout. Chief Test Pilot Russ Stiles.
The military's always had the scout. They had scouts in Vietnam. You know, they called them the Loach, the RAH-66s and the RAH-58s. They couldn't operate at night. They were relatively vulnerable to ground fire. They had no sensors, so they couldn't see very far away. But the environment changed, and now in order to survive, the military flies at night. They fly in bad weather. They want to see longer ranges. The threats are much more lethal. They want to build in stealth features. So the role is kind of the same. It's just that the environment has evolved to be much more complex than it ever was. The Army will end up with basically 2 tactical vehicles. The Comanche will do the scout and light attack, and the Apache is not being replaced. That's to augment the Comanche with heavy attack capability.
Before it's operational, the Comanche will be one of the most tested weapon systems in military history. Next. The Comanche has the capacity to overturn some of the tenets of ground warfare. It will direct artillery fire, call in close support aircraft, as well as Apaches. It will kill tanks and trucks, even shoot down other helicopters or aircraft. The U.S. Army is bringing it along slowly. It wants to get it right.
The bottom line is the government, the Army specifically, will know more about the capabilities and shortcomings of this machine than probably any other system we've fielded and procured. And I don't care whether you're talking tank, howitzer, machine gun, gas mask, the whole shot.
The $2 billion Comanche is entrusted to 4 of the best test pilots in the business. Nick Lampos, Chief Test Pilot Russ Stiles, Chief Warrant Officer John Armbrust of U.S. Army Aviation, and Reg Murrell. 3 civilians, 1 soldier. They fly the prototype on a strict daily rotation. Chief Warrant Officer Armbrust has been part of the test team from the beginning, a revolutionary step in aircraft procurement.
My first flight in Comanche was, I believe, flight number 8. we've had less than 10 hours on the machine. That's unheard of. Usually an Army or green suiter, as the contractors like to call them, would not see the inside of a cockpit for flight purposes for several hundred hours after development occurs. The primary thing that has been retained throughout the years was a recognized shortcoming in the Army's ability to conduct airborne armed reconnaissance.
The Comanche is being tested in repeated flights over the swampland of central Florida. Sikorsky's Development Flight Center at West Palm Beach. Here, aeronautical engineers, technicians, and the test pilots engage in the painstaking task of working up a radical new airframe. In the hangar, the pampered prototype. Engineers are up before dawn to check her out. A failure at this stage might well mean the end of funding.
Those have been raised somewhat.
The day begins at 6 a.m. for the Comanche team. Pilots are briefed, then briefed again on what is called the card, a detailed list of the maneuvers they will perform.
Go out. Primary one, with the tip weights removed, is a tail buffet pylon pressure survey. What we're looking to do is get a baseline.
2 flights are scheduled. Modifications will be made to the Comanche between flights. Slight changes in weight distribution to check the effect on her performance. Everyone attends these early morning briefings. All 4 test pilots, all of the engineers, and the customer.
Objectives.
John Armbruster and Reg Murrell have drawn today's mission. The Comanche can be flown by a single pilot, but in this test regimen, nothing is left to chance.
There's always 2 of us now. You don't go out by yourself, and we divide the duties up. One person is usually flying the aircraft, executing whatever test point we're required to do, and the other person is doing a combination of housekeeping functions like starting and stopping data records, helping the pilot on the controls fly the parameters as required. Also, of course, watching out for the monster to come out of the closet, so to speak, and then be prepared to assist if there is a problem.
Okay, that was Danny.
The monster in the closet, the sudden, unexpected failure of some overstressed part of an untried aircraft, is every test pilot's nightmare. And there are no ejection seats on a helicopter.
We wear parachutes, and we have a system on board the aircraft where we can jettison all the canopy windows and climb out that way. I wouldn't say it's the most efficient way to get out of an aircraft.
Personally, the only time I would do it is if I'd lost control of the vehicle. In other words, I just can no longer control it, or maybe if I was high enough and on fire, I mean physically on fire. Those are the only 2 times I could think. Otherwise, it's like every other helicopter. You take it to the ground.
3, 2, 1, arc.
Ooh, that's pretty. 1 foot to pathfind now.
Every minute stress and strain is recorded as the test pilots patiently and systematically expand the Comanche's flight envelope. Radio transmits the data to a telemetry room where the engineers know more about the aircraft than the pilots flying it. Engineers like Rich Land.
We have several hundred parameters flowing in on our telemetry stream. We probably dwarf what they had on like an Apollo moonshot as far as the amount of data that's flowing in here for this. One of the goals is to evaluate the aircraft at higher load factors. Load factor is G's. We plan to expand that envelope out to a little over 2.5 G's at 165, 170 knots. We may have structural limitations, and this is the first time we've been there.
15 seconds would be delightful.
Now hold that.
Input module's well within limits, only about 0.5.
The aircraft is flying a flight test and flying conditions that we've predefined in our pre-flight briefing. And on board the aircraft, we have sensors throughout the aircraft monitoring performance characteristics of the aircraft as well as loads on the different structural components. This is the first one of this type of aircraft, And we have to know doing what maneuvers causes what loads to what parts to make sure we've designed it correctly.
Hey, you want that one repeated? We got a little fast on it.
I didn't see you get all that fast. Go on to 80.
I can kind of feel things, and when something gross is happening, like the rotor is stalling or something, I can tell. But when some particular piece of the aircraft is seeing higher stresses, of course I can't tell that, so they use their gauges to look at that. Once they've decided that we're still within our expected parameters, then they'll have me go to the next step.
Initial parameter 400, CIS MPFC, going to 100.
Roger the hover and enjoy it.
The fan torque loads are shown on this trace here on the fan gearbox. The main rotor gearbox torques outputs are here. We have that in analog format here on the strip chart. We look at these wiggly lines kind of like a doctor looks at an EKG, and it tells us something.
The key points are 89 and 100.
Okay, going to 80.
We start small, we do a maneuver, we look at the data, and then we do it a little bit harder, and a little bit harder, and a little bit harder until we've explored the full envelope. We keep doing that until we hit a place where some point on the airframe can't take it anymore.
Tip and standby is confirmed.
Thank you.
Another mission complete.
As a pilot, you have to devote so much of your attention to just flying the machine, to keep the greasy side down, to stay out of that tree, to react and respond to the changing flight environment. Probably about 70% of your time you devote to flying the aircraft. They automated the flight control system here. The hope and desire is that we'll actually be able to take that 70% and reduce that to 30, thereby opening up more of the pilot's available attention to apply to the mission. Then when you add on top of that the capability, both in acquiring, tracking, engaging, and reporting targets that the automated and the mission computer cluster and all the sensors on the aircraft provide us, devastating. It's going to be devastating.
It has taken half a century to develop the military doctrine and the aircraft to enable helicopters to hold a place in the front line of battle. Next. The Comanche is the result of 50 years of military experiments aimed at finding the most effective way to use armed helicopters. As a scout, it will team up with the Apache, a heavy attack helicopter bristling with guns and rockets. With the touch of a computer keypad, the Comanche will send target information to waiting Apaches. In the Gulf War, the Apache demonstrated decisively its ability to knock out heavy tanks. Retired Colonel Ron Perry was on the board that selected the Apache for the U.S. Army.
People tend to mix the difference between maneuverability and reconnaissance and attack. The Apache will be used to attack tanks after somebody's located them and gone to find some more tanks that need attacking.
When the helicopter was first offered to U.S. and European armies in the late 30s and early 40s, they rejected it as a weapons platform.
You know, the helicopter came along, and as in all services or countries, you tend to fight the next war with the equipment and the mentality of the last war.
Korea was an eye-opener for the diehards who couldn't see the promise of these awkward rotary-winged aircraft. The U.S. Army's H-13 Sioux, immortalized in the TV series MASH, alone carried 18,000 casualties from the front lines. A larger helicopter, the Chickasaw, shattered assumptions about battlefield mobility. A dozen of them lifted a 958-man Marine battalion to the top of a 3,000-foot mountain in just under 6 hours. A few Chickasaws were given makeshift mounts for rocket launchers so they could lay down suppressive fire. But the helicopter was still restricted to use as an airborne truck or ambulance, not as a fighting machine. They got bigger and more reliable, but they couldn't shoot. The idea of arming helicopters aroused a vicious inter-service conflict, not only in the U.S., but in Britain and France as well. Air forces had a monopoly on providing close air support. If it flies and fights, said Air Force leaders, it's ours.
The roles and missions thing got to be somewhat of a bigger issue than it probably should have, but that's military politics, which is like civilian politics. Everybody protects their own turf.
Even as the U.S. Army brought giant machines like the CH-37 into operation, it was wondering what would happen to them if they were attacked while landing troops. The Air Force wasn't interested in armed escort helicopters. Things reached the point where the U.S. Army had to test armed helicopters in secret, without official funding or sanction. Experiments were conducted at the Army's aviation school at Fort Rucker, beginning in 1955, helicopters being fitted with 20 and 30 caliber machine guns. The Sioux and the bigger Choctaw tried firing 2.75-inch rockets. The Fort Rucker test unit was not officially recognized until 1958, and even then it was labeled experimental. Ron Perry, who flew a Sioux in Army tests, found early helicopters unsuitable for the task.
By and large, the biggest problem with the early day helicopters was the lack of power. You know, the engines just didn't have enough power to be able to, one, carry the amount of fuel, carry ordnance, and then be able to fly at any high speed.
An aircraft then on the drawing board held promise as a weapons platform. Bell Helicopter's HX-140 had a new lightweight turbine engine. It could lift an 800-pound payload at a range of 115 miles. If the Army had secret plans to turn it into a gunship, it didn't reveal them. In service, the new aircraft carried the designation Helicopter Utility Number 1, HU-1, soon to be called the Huey, and to become the very symbol of American involvement in the Vietnam War. In the early 60s, the U.S. shipped helicopters to Vietnam as fast as they could be produced and as fast as pilots could be trained to fly them. They were the most effective way of moving troops in a country with dense jungles and few roads. Handheld weapons or door-mounted 30 caliber machine guns were their only defenses. Slow-moving, thin-skinned, and unarmed, they were easily shot out of the sky, terribly vulnerable when landing troops. Ron Perry did 2 tours in Vietnam.
After they first went out on the first few missions and taking ground fire, they suddenly realized they'd best have a couple of escort aircraft that carried the ordnance so that they could fire back.
Hueys with machine guns and rockets were deployed as early as 1962. With armed Hueys flying escort, there was a sharp drop in the number of troop-carrying helicopters lost to ground fire. Armed Hueys were labeled gunships. Unarmed troop carriers, unencumbered by weapons and ammunition, were called slicks. Both flew at 1,000 feet or higher to avoid small arms fire from the Viet Cong in the jungle and paddy fields. Approaching a landing zone, the gunships moved out front to lay down suppressing fire. The gunships orbited until the slicks disgorged their riflemen and lifted off the LZ. The Huey gunships were far from perfect. The weight and drag of their weapons loads slowed them down so much they were hard-pressed to keep up with the slicks they were supposed to escort. They couldn't carry armor to protect pilots and their vulnerable engines.
When we'd go out over those hills, we'd be doing like 40 miles an hour because to clear the 4,000 or 5,000 foot mountains that were in the area, they weren't huge. With the ordnance and the people and fuel, just took a lot.
Constant efforts were made to improve the gunships to overcome their deficiencies. New models, the Huey B and C, emerged from Bell's factories. They had a more powerful engine. New purpose-built weapons were mounted, machine guns on a hydraulic turret, pods of rockets that could be set for single fire or selfies. Losses still mounted.
In a 30-day period, we went from 24 Charlie models to 15 left. We had lost that many aircraft in that 1 month period.
From 1965, the U.S. military was totally committed to the Vietnam War. The Air Cavalry Division went into action. There was tactical confusion. Artillery, close support jet aircraft, and helicopters, too much high explosive in confined areas.
You take the Air Assault Division, which has hundreds of helicopters, 200 and some odd. They're moving every day with the various brigades. Moving large numbers of helicopters in the same area that you have, fighters and fast fixed-wings coming through is a difficult task, coupled with artillery firing and other things. Most people think that the losses of helicopters in Vietnam all came from ground fire. They really didn't. And one could say it's pilot fatigue. It really wasn't that as much as it is when you get a helicopter loaded and you're flying at altitudes with a lot of ordnance and you're going into small LZs. Invariably, somebody clips a tree. Invariably, something happens. And if you're over mountainous terrain, invariably it would end up with a major accident of one form or another.
One pilot crashed 4 times in a single day. Few escaped unharmed.
I've also taken a round off a chest plate, and it's gone into my chin, and another one off an arm. But by and large, I was always lucky.
Hueys used for medical evacuation, usually flying without escort, suffered terrible losses. Of 1,400 medevac pilots, 490 were killed or wounded. In total, the U.S. lost more than 2,500 helicopters to enemy fire, another 2,300 to accidents. The Huey proved a very capable airframe. Later models are still in service, but the hunt was on for the perfect helicopter, more particularly the elusive, perfect armed helicopter. The Army and the Air Force finally ended their bitter feud over armed helicopters in 1966, just in time for the Army to take delivery of the first purpose-built attack helicopter, the AH-1, the swift and slippery Cobra. The Cobra's gunner sat in front in the 2-man inline cockpit. The Cobra was the first true gunship. Some armor was provided for the crew and for vulnerable engine parts, and it was fast. It carried 7.62 caliber miniguns that could put out 1,600 rounds a minute on slow fire, 4,000 rounds on fast. Its small frontal silhouette, 60% smaller than the Huey, made it hard to hit.
We almost never lost a Cobra out there. And I think the reason being, even though the engine power was not that much different, the Cobra was only 3 feet wide. So by and large, when you took rounds, you took them through the rotor blade.
Cobras reached Vietnam in September 1967. A few months later, in the Tet Offensive of early '68, they played a key role in repelling nationwide attacks launched by the Viet Cong. At the tail end of the war, U.S. gunships accompanied South Vietnamese troops on a major incursion into Laos, a disastrous attempt to interdict North Vietnamese troops and supplies heading south on the Ho Chi Minh Trail. There, for the first time, they squared off against tanks. They destroyed 24 Soviet-built tanks over a 2-month period with wire-guided missiles. But Soviet surface-to-air missiles took a heavy toll and forced helicopters to adopt new ground-hugging tactics.
As the armament got better, you flew lower and lower and lower, whether it be a missile or a gun. You know, we went into Vietnam with this stay-alive attitude that said, I got to be at 1,000 feet, and everybody was taking a lot of hits. Pretty soon you begin to realize that if you get down close to the ground, you fly over the guy before he sees what you're doing.
With the North Vietnamese victory in 1975, the U.S. rethought helicopter tactics with the hard lessons learned over the long course of the war.
Everybody began to realize that if you're going to operate NOE low level, you have to have a twin-engine aircraft. There's just no way that with a 200-pound engine you're going to survive over long periods at high gross weights, carrying a lot of ordnance in a single-engine helicopter. So right off the bat, both the lift helicopter, the Black Hawk, was developed to be a twin-engine with the safety that could carry troops, and if you lost an engine, you could still continue on. And the design was such that you could carry those troops on one engine to wherever they were going. And the same thing happened with the Apache.
By the time of the Gulf War, the Apache was ready. It could attack at night, carried sophisticated target acquisition systems. It packed a huge load of weapons. 8 Apaches were the first aircraft across the Saudi border when the bombing campaign began against Iraq. They destroyed 2 air defense radar stations and opened a 20-mile-wide safe path for great fleets of fighter bombers. Now the Comanche is on its way, a scout helicopter with tremendous firepower. A look at what's inside the remarkable Comanche, next. The Comanche is the most sophisticated helicopter ever built. It's agile, it's fast, and it's exceeded everyone's expectations.
We don't know what the top speed is yet. Typically, in a new development helicopter, Black Hawk, Apache, name them all, when you get to the point in your flight test program where you're trying to demonstrate maximum level flight speed, it seems as though you're almost always 10 to 15 knots short of what you should be. The requirement in our specification called for a maximum level flight airspeed of about 160 knots true. Well, we went out and got 171 knots true, and that's unheard of.
My phone message says we're out flight testing the world's greatest flying machine. The maneuverability will be unlike anything any helicopter pilots have had before.
I'll bet you someday we'll roll this thing at a hover without any forward speed on the aircraft at all. That's my prediction.
Not yet pushed to the limit, the Comanche has climbed 850 feet in 60 seconds. Test pilots have flown it sideways and backwards at 70 knots. And with its complex sensors and weapons, it can be handled, if necessary, by a single pilot. Russ Stiles.
The aircraft's designed to be single pilot operable. A single pilot can fly the machine and, like I say, do most missions. In a combat environment, it's a very, very stressful environment. And having 2 people to bounce ideas off each other, to confirm whether something is a target or not, tends to make them more effective than just one person. So 2 cockpits, they're identical cockpits. We put the pilot in the front seat because he has the better visibility just to look outside. And the back seat, we call him a co-pilot gunner, but he's really a second pilot that can do everything the pilot in the front can do. We use what we call fly-by-wire system, which means that the pilot's controls are not connected mechanically to the rotor blades. They're connected directly to a set of computers that then interprets the pilot's commands to the proper control activity to the rotor blades, and then makes those controls through a set of hydraulic actuators. Now we have 3 fly-by-wire computers. So we put one fly-by-wire computer inside this hatch. On the other side of the aircraft, there's an identical compartment for the second fly-by-wire computer. And then just for safety's sake, right behind the co-pilot's head, there's a third fly-by-wire computer. If one processor fails, there's an executive program that reprograms what software was running on that processor to run the spares. And when electrical power starts going down because you have generator failures, it smartly determines what equipment should be powered or not and turns off the non-essential equipment without having the pilot to intervene. So we have an aircraft that is close to self-healing as probably anything out there today.
The Comanche's unique canted tail rotor enables it to spin 360 degrees in 4.5 seconds.
The fantail, as we call it, started out really with 2 requirements from the Army. The first requirement was that they needed extremely high maneuverability in the yaw axis and wanted a shrouded fan for safety reasons. It turns out then, as we embarked on the design, that we could also make it very quiet by selecting a low, relatively low rotor speed. As you can see, the fan is canted slightly. 2 reasons for that. One is for the radar cross-section. Secondly, oddly enough, the canted fan allows us to put more of the loading towards the aft end of the aircraft because it gives a component of lift. Well, one of the more unique aspects of the aircraft is you see no real visible exhaust pipe. Now, from the camera angle, you can see the nozzles, which are pointed down under the aircraft. And this is to address the infrared signature of the engine, which is the primary source of heat on the aircraft. And quite simply, it's a high aspect ratio exhaust that uses cooling air from the rotor on a slot on the top and mixes with the exhaust gases and provides a very, very cool signature. Pretty much looking like it's going to be not viewable by infrared heat-seeking missiles at any kind of reasonable range. The skin of the aircraft, again, is another unique aspect of the design. The skin carries none of the loads of the aircraft. Then the skin is just there to give aerodynamic qualities and also shaping for radar cross-section. One of the big advantages to this is that we can make over 50% of the access area on the aircraft is panels, things you can open up. And the crew can get in and access the engines, the air conditioning, everything they need to from right here. Second advantage to that would be in combat. If you took a ground fire where it made holes in the sides of the side of the aircraft, this skin, because it's carrying no loads, is quite tolerant to large holes. The rotor is an all-composite 5-bladed rotor with flex beam bearings, so there's no oil up there. In fact, to get the feathering in the rotor needed for control, we just twist the beam. And the beam actually runs from the main rotor hub all the way out to these 4 bolts here. And what that does for me is it makes the aircraft respond very quickly to control inputs. It also makes it feel very solid once the inputs are made. The other unique attributes of it include aerodynamic shapes that have been chosen for low acoustic signature. The 5 blades makes for a very low vibration design.
Until the Comanche, the Apache heavy attack helicopter was the most advanced in the world. But with its HARM and Hellfire missiles carried outboard on stubby wings, it registers strongly on enemy radar. The Comanche's weapons will be carried inside, in bays now jammed with sensors.
We fold the weapons internally for a couple reasons. Again, to maintain that curvature, shape, and also to protect the weapons. A lot of these weapons have very sensitive seeker heads on them, and by putting them internally, we can keep the seeker heads out of the sand and rain or snow or whatever. This is actually a really good view of the aircraft head on. This is the way the enemy sees the aircraft also. And you can see the various facets, again, there for radar cross-section. I think some of the reasons for this is sensitive, if not classified, but generally what happens with these facets is it allows the radar to be directed in a specific direction away from the receiving antenna. It's as simple as that. In all other aircraft, we had a myriad of switches and dials and gauges, and to start the aircraft, you had to put all the switches in a certain position and then turn the rotor up and move the switches to another position, then go fly and move them. Well, what we've done is we've modeled the flight into the computer, so the computer knows when it's on the ground and the rotor's not turning, the switches should be in this position. Then once the rotors turn, they should be in that position. And the computer does all that for me now. So I don't have to monitor those gauges and look for the little needles going into the red zone. The computer monitors the systems for health and tells me only when something's wrong. So when a generator fails, in other aircraft, you might have had to move a couple switches to bring the other generator onto the bus that failed. Here, it just does it automatically and says, oh, by the way, I did this for you. Hope it was okay, and, but continue on. Well, the nose here is just the mock-up, but it represents our electro-optic sensor system. It's really in two parts. The top part is the night piloted system. This is really our eyes in the night. If you can imagine, this device swings around and is directed by the helmet, the pilot's head tracking system. And wherever I look, then I get an image developed by this sensor projected onto my helmet-mounted display, and that's how I see at night. The bottom part, then, is what we use to find targets. And in the Comanche, we have a system that scans passively across the battlefield where we would direct from the cockpit. So it's moving back and forth very quickly as we travel along looking for targets.
Flying the Comanche into combat next. The prototype Comanche is far from complete. No radar or infrared sensors and no weapon systems hidden within its slim fuselage. But its designers know exactly how it will perform. A computer software program takes the RAH-66 Comanche into battle. Comanches will fly NOE, nap of the earth, hiding behind buildings to avoid shoulder-fired missiles and other ground fire. Pilots are already flying combat missions in the Comanche in Sikorsky's full mission simulator. Their performance and that of the aircraft constantly monitored by engineers. With the simulator, Army generals are able to put the Comanche through battle scenarios, so they'll know how to use this new weapon. The Comanche program got the go-ahead in this simulator years before the prototype came off the line. Engineer Rick Bingham.
The Comanche was developed and awarded to Sikorsky and Boeing prior to the Army actually ever flying the real aircraft. They had a fly-off of the aircraft, but that all was done in simulation.
In the simulator, a Navy or Marine version of the Comanche leaves a carrier to scout an enemy shoreline.
In the cockpit, we've developed a complete replication of the mission equipment package, which includes all the weapon subsystems, the target acquisition subsystems, and any of the other flight instruments. We also provide for the pilot a threat environment. The helmet is a dual-eye helmet with semi-transparent lenses, and it provides in the helmet all of his symbology, all of the flight instrumentation which is necessary to fly the aircraft. It also provides a means of knowing exactly how the aircraft is performing. how much power he's using, how much speed he has. This is a tactical simulation center, and in here what we do is we are able to monitor our simulation facilities. When we have VIPs such as generals, they'll sit over here and monitor the experiment that their men are doing in the simulators. We have the capability in this facility to link other simulations into our virtual world. So we can have many pilots flying many different manned simulators, all interconnected, playing on the same battlefield.
Scout helicopters have about 10 seconds to pop up and gather target information before they become a target. The Comanche makes every second count.
Let's imagine we've gotten to our point of observation, and we've selected a masked position, which means the aircraft is concealed. And then we set up our systems by selecting ground search mode, which puts the sensors into a situation where we can now scan the outside world in the direction that we think the targets might be. And I look on my map, and on the map shows a dashed line that gives me the area that this system's going to scan. The whole point is to try to set the system up before you break your concealment. So we want to minimize how long we're exposed to the enemy. The FLIR sensor automatically sweeps across the area that I've designated and attempts to find targets by recording the imagery it sees and then analyzing that imagery very quickly against a library of targets. If it finds a match between something in the image and that library of targets, it shows me on the left screen small field of view cutouts of the target locations. Then we're going to recover to our point of concealment and analyze the data that we have.
Red blooms show the growing contours of the battlefield that are above the Comanche as it sinks out of sight.
Now I can play back that imagery by going to a review mode, but the first thing I'm going to do is look at the frame that the targets were found, and then I can zoom in using a digital enhancement technique, and I see that it looks like I have 4 good-sized trucks. And the next thing I would probably do is send that data out on the digital nets. And now the people that I work for, my commanders, have that information just as I have it.
Profiles of every known tank, truck, or other military target will be stored in the computer for instant identification.
If there was a high priority target where we want to take it out with our own aircraft, I could unmask, select the missile, open the weapons bay doors, and launch. And the missile's away, I've taken out my high priority target, and I can go to a position of concealment again.
The Comanche can relay its target information directly to Apache heavy attack helicopters. The targets will appear on their battle maps exactly as they are displayed on the Comanche screen.
And this is where the quarterback of the digital battlefield comes into play. I can use these graphical tools to then put together a plan and a strategy for what I'm going to do.
In the simulator, warfare has all of the attributes of an expensive video game. Russ Stiles knows the real thing is not a game.
When you sit in the simulator, it may seem that way, where you push a button and targets appear and you give them labels and you send them off to this notional battlefield commander. Having been in combat myself, things are a lot different when it's serious, when it's really at night and there's really people out there that are trying to kill you. The video game, it becomes very, very businesslike, and the video portion of it just becomes a better tool than we ever had before. A very, very sophisticated tool, albeit, but just a tool to help the guys do their job better, survive better, and have a better chance of coming home after they've accomplished their mission.
It really is not a question as to whether I think the machine is doing well, or Russ or the company or the engineering or any of us weenies in the rear area here. It's the people who are ultimately going to use this thing in the forward areas. We could please ourselves all we want, but if in the end we haven't pleased them, if we haven't given them the absolute very best tool they have, the safest machine, the thing that'll bring them home, keep them safe, and allow them to do what they were sent there to do, then we failed. That's the bottom line.
The Comanche, the military helicopter, comes of age.